Hi. Good afternoon and good morning, everyone. Okay, let me just close this. Okay. So thanks everyone for taking your time to join our webinar session for today, where we're going to talk about how HiveMQ enables connected cars messaging. So with us here today, we have two of our speakers from HiveMQ, Dimitri and David. Dimitri is the Global Channel Partner Manager at HiveMQ. His experience includes more than 20 years of leading high-performance teams in executive sales and channel management roles at leading technology and software security companies. Currently, he is focusing on strengthening the HiveMQ partner ecosystem. Prior to joining HiveMQ, he held the position of Channel Director at Virtual Solution AG. And David is a solution engineer at HiveMQ and serves customers by identifying their needs and providing them with technical support. He has provided project and sales consulting services for many years in the area of data and application integration, data management, and messaging. Using this experience, he is helping HiveMQ customers to achieve the best possible outcomes with their IoT solutions. His main focus is maintaining a high level of customer satisfaction at HiveMQ. So before we start the session, if any one of you have any questions, you can put it into the question box, or you can leave it for the end of the session, because this session is going to be about 30 minutes, so we can have a discussion at the end. Okay, over to you, David. Dimi.
Sure. So I will start sharing my screen.
David,
hello, everyone.
Yes.
Just a quick confirmation. You can see my screen, full screen?
Yes, I can see your screen.
Perfect. So hello, everyone. Today's webinar is about connected cars and how we can basically modernize mobility services using our technology. And the agenda is relatively short. I mean, we try to put a little bit of focus on our company, our product, and how we can basically help to, improve services in various key industries. And the company itself is HiveMQ, and it was founded in 2012, initially as a consulting company. And as part of the consulting, we developed a product in the space of MQTT, a technology that is very well adopted in IoT nowadays. And basically the company itself, the vision of the company is to help move data from connected devices in an efficient, fast, and reliable manner. And we have 150 plus customers. It's growing month by month. The number is never correct, but quite impressive use cases, specifically in connected car, with basically the largest car OEMs worldwide have HiveMQ under the hood to basically connect devices and their data centers to provide services to car owners. And on top of that, smart manufacturing, various use cases which will be covered later. Our customer base, what is the primary use cases that we do is basically building digital products for our customers. On top of what they have already, on top of their physical products, you digitalize them to enhance the service and improve customer experience, and also, of course, the ever ongoing issue, make your operations more efficient. And with that, we basically serve multiple verticals already. As said already, car mobility is one of our major use cases, but also manufacturing, smart assets, many use cases that we'll cover later. And basically a common denominator of challenges that these customers have, a lot of these services that they provide are customer facing. So obviously these services need to be reliable. They are business critical because customers are directly affected by it, and you have an ever-growing, demand that increases. New customers are onboarded, and you need a platform that basically scales with this growing demand. As it's often in the public internet, you have mobile connectivity. The connectivity needs to be cost efficient, and of course also secure. I mean, security is a issue, a problem that always comes with public internet. And of course, as you have many devices connected to a platform, you need to be able to observe what is actually going on in the system. So if there is a connectivity issue in an area, you need to understand what's actually happening to the devices. And integration into IoT data, of course, you have devices on one side, you have business systems that actually do something with your data, that do analysis, to do all the sorts of magic to basically provide the digital service to the customer. This integration is obviously also an important challenge for them. So what is actually the technology that we provide, and what do we do? We basically provide an MQTT broker. And MQTT is an IoT messaging protocol that pretty much becomes a general purpose IoT messaging protocol because of its characteristics, the way it's designed. It's specifically for reliable communication over unreliable channels. So it has a very small footprint, both on the client, so that it can run on very small devices, but also on the bandwidth, so that you can maximize basically what you can send over the internet and consume also in the device in a very efficient way. And scalability, of course, is built in as well, because as said, you serve a lot of customers with this protocol. And just to give a little bit of an overview what MQTT is, it's basically a publish-subscribe model where every client, every application, or every device connects to a central broker, and they can then both publish messages to the broker, and basically another device can consume it through publish-subscribe mechanism. And also vice versa, it can every subscriber can also publish, and the consumer on the left side can receive message. So bidirectional communication to open a door, but also send telemetry data from the car, for example. So what is HiveMQ's role in this? It's basically a MQTT broker. The whole idea behind MQTT is that the client is very lean, very small, that it has very little responsibilities, and a lot of the responsibilities actually on the broker. And therefore, it's critical to to make the right choice about the broker and choose one that has a certain set of characteristics, and HiveMQ is basically the de facto leader in this market nowadays. And the way we do is basically we provide a cluster of brokers that can scale, that do data replication for high availability. We do full message persistence, meaning that we reliably send messages from left to right and right to left. We have multiple robustness features to also withstand scenarios like a storm connect when an internet outage is there and a lot of clients are reconnecting at the same time, when they send all the outstanding messages. All these use cases that you typically see in IoT and not so much in traditional IT. Security, of course, we provide TLS, RBAC functionality, access control, to make sure that a single client can really only do what it's supposed to do, and also in an encrypted fashion. We provide observability and also integration into observability tools to monitor system health, understand the status of the client. Interoperability, that's basically because we are MQTT compliant, fully MQTT compliant with all MQTT versions, and HiveMQ was actually also the first MQTT 5 compliant broker. And this basically means, as MQTT as a protocol is similar to HTTP, it's fully based on a protocol standard level, meaning that a client and a broker are all interchangeable, because the MQTT protocol itself defines how they need to communicate, meaning that you can really plug and play components together. And with on top of that, we allow to basically integrate anything using our extension framework. And there we also provide a couple of out-of-the-box extensions, which I will cover later a little bit. But also you can develop your own extensions to integrate into your backends as you need and run anywhere, meaning we can run on-premise, in Docker environments, Kubernetes, and basically with that also in all major cloud providers. So a few words about scalability and high availability. So HiveMQ, as said, works in a cluster fashion. It's a masterless cluster, meaning you can elastically scale HiveMQ broker and broker and broker and broker to serve more clients, to serve more message throughput, but at the same time, they also do data replication to basically provide high availability if one broker node, for example, goes down. And, those messages, those connected clients, of course, need to reconnect to the cluster, but continue in a seamless fashion. And this basically eliminates the single point of failure in your communication. So you have a really, withstanding rock in the middle that everyone can connect to and can send and consume messages from. And this basically also allows to do zero downtime upgrades, rolling upgrades by doing version upgrades, configuration upgrades, and just replace node by node with a new version and provide SLAs of 4 nines, for example. So it's very critical in customer-facing applications that you have a solution in the middle that just is available all the time, and HiveMQ does that through its cluster approach. So for observability, basically, we provide a web portal that the so-called HiveMQ Control Center, which allows you to monitor the system health itself, but also the status of connected clients and basically how they behave. You can really drill into the broker and see what the clients are doing. And on top of that, also we provide a couple of extensions that integrate into Prometheus, InfluxDB, Splunk, and Datadog to really allow you to see the system health also in a broader scope, to integrate it also with the connected applications and see how your overall IoT platform is behaving. And as part of that, we expose a lot of metrics, 800 plus, to really, understand every aspect of the broker and its health and the MQTT behavior on the broker. And these are basically our extensions that I mentioned before. So this is all based on our extension SDK, where you could also develop your own integrations, custom integrations. And these we basically pre-built and they're pre-installed already. You just need to activate and configure them. And they provide connectivity to Kafka, so Apache Kafka, or nowadays Azure Event Hub, or Confluent as the commercial provider behind Kafka. And there you can also bidirectionally move data from the MQTT broker to Kafka and also the way back. So this is a very popular pattern that we see in a lot of customers, that they use Kafka together with HiveMQ to enable Kafka to be IoT ready. The bridge extension basically allows you to geographically distribute clusters worldwide and connect them and basically stream data also from left and right, so that you can centralize and consolidate data in a certain location and consume them closely in other locations. And the security extension is basically, I would always say, a must-have for public internet. It basically allows you to implement access control to really make sure that a particular client, a particular car, for example, can just consume, that it first is authenticated and then it can just consume MQTT traffic in the way it's supposed to. And last but not least, freedom to run anywhere. I mean, HiveMQ is not really, tied into any kind of deployment platform. It allows you to be installed just plainly on a Linux operating system, but also in a container environment. And we provide a Kubernetes operator, a Helm chart, to really also simplify the installation and operations of a HiveMQ in a container platform. And with that, of course, you can also run in a multi-cloud strategy. You can move with our license also from on-premise to a cloud provider and then to another cloud provider. So you're very flexible in terms of operating the system and deploying where you want in the most cost-efficient way as well. And on top of that, we basically also provide HiveMQ Cloud as a fully managed service where we take over the operations for our customers. So, and this is basically the company and the product. And Dimitrios will now show you a little bit what key industries we are serving with that. Do you want to take over the screen, Dimitrios?
I can share my screen.
I guess it's more efficient. Right.
There you go. Okay. Can you see my screen?
No,
it's not shared yet.
Ah, yeah. Well, sharing would be a good idea, right?
Yes.
There's a second step, yes.
All right. I guess now you can see my screen,
Yes.
right?
Yes.
Okay, everybody. So you heard a lot about scalability, high availability, about the importance of connections, not losing connections. Of course, I mean, if you drive with your Tesla autonomous on a road with 120 miles an hour, or let's say Germany, you can do that. Then, of course, it is very important that any message which comes from the car will not be lost or is not lost while it moves from the car to a database or analytics tool, you can imagine. But also, if we have customers in the transportation logistic with thousands of cars in the fleet management, you need to know any minute what happens there. Those four industries you see here are the main industries. However, we have also different other customers in other areas, but those here are the most prominent. And instead of telling you now lots of technical informations or any other topic, I would like to share with you some dedicated use cases we have, because that gives you a better feeling what we are doing and which are our customers. Okay, but first let's state a fact which is extremely important for you and for us. 470 million connected vehicles. This is an estimation, right, on the highways around the world by 2025, right? That means all these cars create kind of contact information, 25 gigabytes of data per hour. So there is also another estimation from Data Group, which says the majority, 70% of all data which are created today are coming from infrastructures, from server farms. And by 2025, this will change. The majority of the data will come from IoT devices, from cars and other IoT devices. So therefore, the importance of HiveMQ and of a connected, digitalized world will increase. So that's just a fact. This is something which shows you a little bit. This is an area, smart cities, where we connect everything around parking management, traffic management, and also fleet management, right? So everything what you see here is connected, and we move the data from where the data will be created, we have spoken before about devices. A car for us is also a kind of a device. However, there can be any kind of device, right? It can be a traffic light, it can be a car, it can be a sensor, it can be a bus, a tube, whatever it is, a battery, right? We move the data from where the data will created to where they're supposed to be. So this is an example, one of our customer, Balex, right? And they needed a reliable, high availability control and monitor system, right? To have in any minute, any second, the exactly data from the traffic lights to the endpoint system where they want to be. So, and they have chosen HiveMQ because we not only move data, but we do it on a way where every data you move are clustered, yeah, and where they can also log files and create nodes. That means they can scale without, David said that before, zero downtime. That means you're not shutting off the system. The system is running continuously, and you just extend by adding additional node clusters from HiveMQ. And we deployed that in Sweden and in Norway, and the Belex plans also to deploy that around Europe. Real-time information delivery. This is more or less the most important fact for them, and that runs with HiveMQ. Another example, which is in Germany here, of course, this is also our base, our headquarter, is SVM, Stadtwerke München called. So what we do mainly here is we have a dynamic information monitor system built for this customer, together with the customer, where the customer who wait for a train, right, knows exactly any minute or what time a specific train will come, right? You see on the displays in the stations, yeah. Thanks to HiveMQ, real-time data where you know exactly when the tube is coming. This is installed a few years ago. It runs very, very well, and we have successful deployment in more than 500 monitors in the stations and in more than 2,000 buses. So, and we move the data from where they're created in the bus or in the train to the monitors. This is all real time what you see, and it runs very smooth, very well. This is also an example which shows a little bit everything around mobility services, right? We have here ride-hailing, but we can also implement public transportation. The example which I showed you before, connected cars, I'm going to show you an example here as well. Fleet management. One of our biggest customers is UPS, right? Who's using HiveMQ and MQTT. We have a car sharing customer. I have an example here. We can implement bike sharing, taxis, and of course autonomous shuttles. We also have a customer there. Let me show you a little bit more in regards of connected cars and car sharing. One of our customers is BMW. What we mainly do here is you can share a car from BMW anywhere, and the way they do it is you're not using any key anymore. So you have your app, and with the app, you open the door, you activate the car, you start, and you can run. So all that runs via MQTT and HiveMQ. In the past, they used a different system, which was a problem because it was slow, not responsive enough, and it took more than 30 seconds just to unlock the car. Now with HiveMQ, it just takes less than a second. So that's also the beauty of MQTT. In combination with HiveMQ, it is low latency and very, very fast. So that's also an example how you can utilize HiveMQ and MQTT. Another example is A-Cargs. We have this customer. We have more than 2 million cars connected here, and this is also based. We mentioned scalability. What we do here, we collect telemetry data from the car, and including remote status, driving log, and we can interact, so to say, with the car. We also can send commands to the car. They have a digital key there. Remotely start the engine, climate control, everything you can imagine can be done here. And they have connected to, I think, more than 2 million, in the meanwhile, more than 2 million Geely cars. And on average, we have 350,000 simultaneous connections. And you can imagine this implementation, the HiveMQ implementation, is saving money and saving time, and is the reason. Reliability is also one of the reasons why they implemented us here and not on a different other systems. So also a nice example. This is coming from the transportation segment. Real-time monitoring of autonomous drones from Ethernet. Of course, you can imagine you reduce time and you reduce time to transport medical samples between hospitals. Very, very important part. And you can also imagine you need to have real-time data here, reliable real-time data anytime, any moment. You need to know where the drone is, what the outside conditions are, what happens with the drone, where the drone runs. And we have the customer. The customer is extremely satisfied with our solution. We have no interruptions. It runs smoothly. And yeah, we have, can I say, more than 1.5 million connected. So globally, they like to roll out 2.5 million devices. That's the plan. So it runs everything on MQTT and HiveMQ. Yeah. So that's the last example. It comes a little bit from a different sector, but it's still automotive. This is the customer Daimler Mercedes Daimler. They have a diagnostic system, a VDS system, which is extremely important and critical for the manufacturing process in their warehouses, and which shouldn't go down. Of course, you can imagine they have 24 factories, where they run these systems, and if the system is down later than more than 10 minutes, the assembly line may stop. The reason why they have chosen us, because they know we don't have downtime and we are reliable. We can cluster, as I mentioned before. That means we always have the data, access to the data. So, and in these 24 factories, they have more than 10,000 testing devices at the end of the line, of the production line. And these 10,000 devices, they generate 470 million messages per month. So this is just an example to also show you the capability of our system, right? Regardless if you have 5,000 messages or 5 million messages a month, the system we have here is capable to tackle that. Okay, I think that was my last slide. As you can imagine, we have tons of other customers as well. Let me stop sharing here. tons of other customers. We're more than happy also to discuss with you about your own topic or analyze where you can implement HiveMQ. I think we should come to the questions.
Yes, there are a few questions here. So let me start with the first question.
Yes.
From Saravana. How does it eliminate the single point of failure? Does it applicable for ring network and star network? I think this was asked when David was sharing in one of the slides. So it's about a single point of failure.
So basically, how a HiveMQ cluster works is, as said, it works in a clustered way. So you have HiveMQ installed on separate hardware, and we use internally the so-called consistent hashing algorithm to. So every cluster node is connected with each other in a star network fashion, and they use this consistent hashing to basically define for a message payload or a client session for several different objects. They use this algorithm to define which cluster node is actually the responsible node. And you can configure how many replicas you want to have. And then this responsible node will also create backups in several other cluster nodes. So if the main node goes down, basically the backup node takes over, and using this consistent hashing algorithm, the cluster at any point in time knows basically where to ask for a specific persistent data. And this is all handled within HiveMQ in a masterless fashion. So there's no dependency on a zookeeper or any kind of third-party software. It all happens internally. So, and this means if a cluster node goes down, and the connected clients, of course, when the connected clients of the node, when the node goes down, they need to reconnect to the cluster, but they will be reconnected to another cluster node. And then the cluster node, based on this algorithm, knows where to get all the outstanding information, all the persistent information that were already there before. And it can continue with the session. It gets all outstanding messages delivered. It gets all session information. So everything is as before when it reconnects.
All right. Okay. I hope this answered your question, Sarah. Okay. The next question that we have, what are the supported machine learning models or available models? Example, time series model, this deterministic model.
Yeah, I saw the question, and also the following one. Maybe here we need to clarify a little bit. I mean, HiveMQ is an MQTT broker. And MQTT as a technology is basically a data ingestion layer. It's a communication platform. So what we don't provide is basically the analytics part. We are one component in an IoT platform to basically fulfill any kind of IoT-driven use case. And that means we basically don't do machine learning with the data. We basically are the connector of all the cars, all the devices to your analytics platform. And in the analytics platform, of course, you can use whatever machine learning models that satisfies your use case. Whether it's time series, I guess they all make sense in a certain use case. But to get it clear, we are a communication platform, a messaging platform that scales very large, that allows to connect a lot of different clients. And maybe also a little bit of separation here to Kafka, for example. It's very, very popular nowadays, deployed in many companies to basically provide connectivity between applications, and also to provide streaming, analytics, and these kind of things. What Kafka fails to do is to serve so many clients at the same time. Kafka is built for, let's say, hundreds of clients, hundreds of applications that communicate with each other. HiveMQ serves millions. So that's one of the big differences. And the simple difference of the Kafka protocol, which is proprietary, it's owned by Kafka, and you need to have the Kafka libraries. MQTT is really standardized on the protocol level, meaning you can even buy a hardware appliance that has a MQTT client pre-installed and connected to HiveMQ, but theoretically also to other MQTT brokers. It's all on the protocol level. It's exactly defined how they need to connect, how they need to publish, how they need to subscribe. So it's very much for interoperability, this protocol. And this is also why it's so popular, in my opinion.
Right. Okay. All right. Done. Okay. Next question. What are the parameters? Oh, okay. You're good.
This goes in the same direction as I just said. I mean, any parameter, we allow basically, MQTT is the protocol is data agnostic. You send a payload, and in this payload, you can define, which data you want to send. And it's basically your design, or basically this is also why we are sitting here together with Matrix Event. Matrix Event as a system integrator can help you to build such a system utilizing HiveMQ. And HiveMQ is basically one very important building block in such a IoT platform to do traffic light monitoring or connecting your cars or do smart manufacturing and all these different use cases.
Yeah.
Okay, thanks for that. Okay, we have a question from Tommy here. With reference to use cases shown, was the HiveMQ broker client was embedded into device-specific firmware?
Sorry, I didn't see it. Can you repeat, please?
This one is in the chat. With reference to use cases shown, was the HiveMQ broker client was embedded into device-specific firmware?
Maybe to also clarify here a little bit. HiveMQ itself provides a client library. We are a Java company, so we provide a Java-based MQTT client. But actually, you can use any client that is out there. Actually, on our webpage, you can also find an encyclopedia. There are clients in C, embedded C, C#, Java, ours, for example, and Paho, Eclipse Paho is a library in many programming languages where you can connect, which you can use in various programming languages to connect to HiveMQ. And this is all based on this, again, on this technology MQTT. And as long as the client and the broker is MQTT compliant, HiveMQ is fully compliant with all versions. Basically, you can use any client. And Java, as you know, has a little bit a larger footprint. So on larger applications or machines, Java may be used. But often also customers use more, let's say, lightweight programming languages, embedded C, for example, or C. Paho libraries. Paho is a very popular one. It's open source and also maintained for quite a few years already. I hope this answers this somewhat.
Yeah, I hope this answers your question, Tommy. Okay, we have another question. Which other car vendor is using HiveMQ?
Okay. Maybe I can answer to this because it's the less technical. I mean, mainly every big car vendor around the globe. We have Ford, Autonomic is a car vendor. Jaguar is one of our car vendors. BMW, Daimler is using it. ECARX, the car Tesla is using us. Rimac, the guys who are building very fast e-cars, and Audi and Volkswagen. Volkswagen is using so you see I more or less stated quite a lot vendors.
And actually, we are also in talks with many others that are modernizing their platform just today. I mean, every company has a different digital journey and is in a different stage. And traditionally, we are a German company. We've grown with the German vendors and have of course, a closer connect to them, but we are in contact with many others as well. I mean, I'm in the sales organization. I'm talking to many others as well.
Yeah,
that's
we cannot speak at this moment about them, but there is also some vendors in Japan, you can imagine, who are talking to us.
Oh, Japan as well.
Yeah.
Okay, we got a question here. Let me bring it up. In connected cars, there is always a challenge like connectivity when the car park in the basement area where internet connectivity is not there. So how MQTT or HiveMQ can address this?
Yeah.
I mean, of course, if there's no connectivity at all, there's also no MQTT connectivity, to make this clear. But the protocol MQTT was specifically also designed for detecting that there is actually a disconnect, because in TCP there's this problem of a half-open socket where actually both parties don't really know whether they are still connected to the other one, and MQTT on top of the TCP protocol, it's basically on top of that, provides internally also a keep alive mechanism to make sure that at least the client and the broker know that they're not connected with each other anymore. And basically once the car leaves the basement or the tunnel, it would need to reestablish the connection and can basically use the MQTT persistency features to get, for example, outstanding messages immediately once it reconnects. So it's all built around, unreliable networks, and that the client doesn't need to do so much to basically reconnect and get also all outstanding subscriptions automatically when it reconnects.
And maybe to add to this, even in that kind of environment, you might have a 2G connection, right? This is what happens to me all the time. And MQTT is built so lightweight, right, that we still get data because the data are really small, which we move around. So that means even a 2G connection can already work for us, right?
Yeah, and maybe also an interesting side note, I think it was BMW, they actually tested when the car stands. And with MQTT, basically you have persistent connection all the time to your data center. And when your car stands and just basically consumes battery, it can keep up this connection for 7 days just on battery to be, let the motor start, let the climate start, all these things. So you have a fully standing connection, can always interact with the car in a very cost and also battery and energy efficient way.
Yeah.
Also, they can start the car from anywhere.
Yeah.
You probably shouldn't do that, but you can unlock it, you can start the heating system and all these, these convenience features.
That's so cool.
Of course, you need to be connected to the car to do this.
Yeah. Okay, we got a few more questions. Let me bring it up. Okay, since MQTT is lightweight protocols, do we need to use OPC UA along with MQTT when we receive more number of data from sensors?
No, I mean, OPC UA is a different protocol simply. I mean, to be honest, we consider it a little bit as a legacy protocol. It's a lot of our customers are migrating away from OPC UA mainly for the reason because it's very expensive, it's very complex to implement, and because it works a lot on polling mechanisms where you don't really get real-time data. With publish subscribe, any sensor can send data when something changes. It sends it to the publisher and any interested party gets this information. With OPC UA, you have to basically ask the sensors, and with a lot of these legacy protocols, you need to do this. And this is very network intensive. and as a result, very cost extensive, and you need a big network bandwidth to basically emphasize this or to utilize this and get at least close to real time. And with MQTT, with this pub/sub model, you have a completely paradigm shift in the end. And this is also the difference to this SMS and HTTP, which was used in the beginning for connected car. You needed to kind of notify the car that you actually, want to do something, and it was a very complex streak, which, as Dimi pointed out, took 30 seconds to establish, and with MQTT, it's just in under a second. So they live often side by side. OPC UA actually, in the new standard, also wants to provide MQTT compatibility so that you can connect it to MQTT. But we also see it side by side often, and you have hardware, software gateways that do kind of translations into MQTT. And as a side note as well, there is an initiative called SparkPlug-B, specifically for the smart manufacturing use cases, but actually it could also expand outside of that, which defines also a kind of a data standard. How should a device or an asset, how should this work, this life cycle be reflected in terms of data? So when the asset comes up, it shall send a birth message to the broker and tell every interested party, hey, I'm here. When it goes down, it sends a death message, hey, I'm gone. Telemetry data, it sends in a specific way. So it defines on top of MQTT, which is data agnostic, it defines how actually components should interact with each other, which again allows more interoperability and plug and play in the long run. And yeah, it's kind of competing to OPC UA, but much more lightweight.
All right. Okay, let me set this. Okay, next question. How does HiveMQ Sparkplug related to overall solution?
I mean, SparkPlug B is a specification. It's a standard that is also evolving, and I think we'll get a new version this year. And maybe also as a side note, HiveMQ is actually both in the MQTT standardization committee and also in the SparkPlug standardization committee to really drive these standards. And SparkPlug as a standard relies on MQTT as the communication protocol. So this means you could also use other MQTT brokers, of course, with SparkPlug. The benefits you get with HiveMQ are this, what we basically said: reliability, high availability, scalability, throughput, latency. So all these, let's say, non-functional features to really that make your overall the characteristics of your IoT platform better. And SparkPlug as a whole sits basically on top and defines the standards how the connected devices and components interact with each other. So that's kind of the relation.
Okay, thanks for that.
I hope.
Okay, let me see. Okay, so Tommy, thanks Tommy for your question. Anyone have any other questions that you want to ask? No. Okay, I think we have answered most of the questions already. So wait, let me just pull up my slide here.
We can also, after this web session, we can provide you information, or we can have a separate individual web session specifically for you. If you have a specific scenario in place, we can analyze that together with you if you like.
Yes.
Just approach our partner, and we will set up a call with you guys.
Yes. So thanks everyone for your time, and for all our guests, we'll be in touch. Okay. Thanks.
Stay safe.
Stay
Bye-bye.
safe. Bye.
Thank you. Bye-bye.
Thank you.